Alright, so this is part 3 of cleaning our data using numpy and Python. So again, we build a two-dimensional array. We're gathering temperature data, and we have some missing data. One of the things we might want to do is just put a 0 value. So we can use fill NA to store a new value anywhere we want for the missing data. Now, if we run this, you'll see that we have our original means. So this is our original data that we're missing the values, and here's our original means. Then we replace the missing value with zeros, and here's our new means. And as you can see, when we calculate the mean, the missing data is just ignored. So sometimes you just want to leave the missing data in there. There's not really a lot of reason for changing it to a new value that you just make up. Especially putting a 0 in there, because it changes the calculations. And it's going to be the same for median and all the other calculations. If the data is missing, it just ignores it. If you put a value in there, it starts screwing up the values that you're going to calculate. So you can do that. You can replace all the missing values with something, but be very wary of that when you're working on it. Now you might think, well, can't we replace it with the mean? And sure, we can replace it with the mean. If we look at cleaning 10, we have the same data set. We're missing all the data. We print it out. Now, for this to work, I need to transpose my data. So I transpose it, and now I calculate the means. And then here's the cool part. So instead of just sending a fill NA with a number, I send it a dictionary. And the dictionary is the index location and then the new value to replace. So in index 1, this is the value I want to replace all my missing data. For index value 2, this is the value. And those are the values that come from the means here, which is a list of means here. So I can replace all the missing values with the appropriate mean. So the mean value for the garage is where I'm going to replace all the garage values with. Now the interesting thing is, if we do this, there's the original means, and there's the new means, which if you look, haven't changed at all. And of course it makes sense, because if you put the new mean values in there, the mean isn't going to change. But if you would be graphing this data or doing something else with this data, putting a number in there may make sense. And putting a mean value in there might be the way to go. So if you're putting temperature values in for different rooms, and you have the mean value temperature for that room, and you're missing a data point, putting a mean value in could make sense. There are other ways to fix that data as well, and we're going to look at those. So if we look at cleaning 11, you can take the value next to it and put it in there. And you can do it from the top down or the bottom up to replace those values. So if we look at this one, so we're using F fill and B fill for front fill and back fill. So we have our original data, and we're missing some values. And if we do a front fill, you can see that some of the values disappeared. These two values didn't disappear because there's no value before that to copy in. So front fill has some issues, but still, if it was 75 degrees today and you missed the value tomorrow and it was 77 degrees the third day, do you want to put the Monday value in or the Wednesday value in for Tuesday? So you can use front fill to put the Monday value in, and backfill to do the Wednesday value. But as you can see, if we backfill, we still have a hole here because the value there was nothing before that. So front fill and backfill works except for the edges of your array, because then it has nothing to work from. So you could run backfill and front fill on both of them, and it would be fine. There's a lot of options about how many values you want to copy in a row and things like that. But really, we're not going to use backfill and front fill that much. But you can look it up if you want to. And again, now we have our starting means and our new means. and they're changing. And they're changing because the values we're putting in there wasn't the mean value for the whole row. It was one of the values, either the top or the bottom, between the missing values. And maybe that's a good way of doing it. Maybe the mean makes more sense, but you're going to have to decide that when you're working on your data set. Let's look at another option. And somebody say, well, if we have the missing data sets, can't we just either use the value that's halfway in between or some other interpolation method? And yes, there is an interpolation method that will fill the holes out. And so we have the missing holes. We interpolate the data, which fills in the values based on the values on the outside. And then we look at the, that was from the last time. We have it. I put a graph on the last one too. So now we have our old data and we have our interpolated data. And as you can see, we have means that are now slightly different. And it can't interpolate from an endpoint because it doesn't know if it's dropped off to 0 or started high and dropped down. It can only interpolate between two numbers. So we still have the issues that we had with backfill and front fill, but the number that's being used is not a copy of one of the others. It's the one sort of in the middle of the two values. So interpolate I like better than front fill and backfill. But to get the edges out values, you might want to use backfill or front fill to fill out those edges after you interpolate. All right, and we're going to run this one more time and just demonstrate with plots what's going on here. So these are, I used to have a one-dimensional array here with some holes in it, and I'm going to graph it. I've used interpolate to fill up the new values, and if you look, here was our original values. You can see the holes in it. And if we interpolate the data in between, we have added the values in between there using interpolation. And, you know, maybe there was another big spike here that we don't see, but maybe our data looks better and it's more somewhat useful to us than having the holes in it. And that's one of the big things you have to start thinking about. Is it better to have no data or an estimate of the data? And is it better to have a smooth chart that looks like you have the data or the real chart that's broken up and I don't know what the data looks like, and you have to do all that thinking to spread the values in between there. And as you're doing data cleaning, those are decisions you're going to have to start making.